Good morning, everybody, and thank you again for joining us for today's webinar. My name is Isabel Halvenes. Today we are discussing a very interesting topic, and it's all about data and how that can be your best friend, also your worst enemy. And I think most of us in mining and metallurgy have experienced that problem. We are very fortunate to have Antony Mello with us today. He describes himself as an operations and business strategy enthusiast who loves problem solving, loves people, innovation, and making a meaningful impact on the mining industry. So a person very close to my heart. Anybody who's enthusiastic about the mining industry always gets my attention. So Antony comes with us with 5 years experience at AngloGold Ashanti as a metallurgical engineer, and he's currently engaged as a consultant at Buma Collaborations, focusing on applying systems thinking methodologies to maximizing the operational system capabilities of business operations. So Antony's passion for social innovation and rethinking the role of business and society is demonstrated by his work, where he works closely with several non-profit organizations in various initiatives driving social change. So we look forward to today's presentation by Antony. So Antony, you're welcome to go ahead if you can start loading your presentation. And we're looking forward to hearing your side of how big data can be your best friend or worst enemy. Enjoy the presentation, everybody. After this session, we will have a short Q&A, and hopefully we can have an exciting debate on some of the issues raised today. Please go ahead. Thank you.
Thanks a lot, Isabel, and thank you for the opportunity. Thanks to Simon as well. As you mentioned, the title of my sort of webinar today is how you use your data and make it your business's best friend or your worst enemy. And I'm glad that you've already given me an indication into some of the audience who most probably experience the same thing. And I think what I'm going to share today might be helpful and useful to most of you. So I decided to start today's presentation with sort of what I hope for you to walk away with. And I thought I should just relay a quick story about my life as a metallurgist. So as I was a metallurgist as Isabel mentioned, at AngloGold Ashanti a short while ago, during my time then, we were involved in a project to get a remote operating center set up. And at that time, which is about 10 years ago, I mean, that was quite an exciting project, and everybody had high hopes that this would be the big game changer, as data then was being counted as being the big game changer for most organizations. And the project kicked off quite well. There was some substantial sort of investment into that project. But unfortunately, the project got discontinued, delivering the real value, which was taking operational data and using it on a almost short interval control basis just to make more effective fact-based decisions for the guys on the operations. So based on that, I just decided to start there. Sorry, clicking on the wrong buttons. Sorry, there we go. Just to say that my talk today is going to be based on some of my experience from then, what I experienced then, and also what I experience now as a business consultant, engaging with organizations who are either going on the same journey or planning to, of now going whole digitalization, IoT, getting data on everything, and just getting these remote operating centers, or business intelligence centers is now they call. And there's a lot of investment that's probably going to go with this. And I'm hoping today I can just highlight a few things that we've picked up through our time as an organization, and some of the things I've picked up personally from my experience working with data and how to make it effective operationally. So at the end of this session, I'm hoping you'll get some insight into what are some of the pitfalls you may want to avoid when using data, how these may impact on your organization if not handled properly, and give some key pointers as to how we're engaging with clients and how you can move your organizations towards making better data-based decisions. So is data the new oil? So data is the new oil is a term that was coined, well, from my research in 2006. And it was attributed to a mathematician who said now data is going to be the most valuable resource, right? At that time, the digitalization journey for most organizations was still at its infancy. People had this high hopes, and people had this expectation that once we have all the data, as much of it as we can get, that will enable us to make better decisions and enable us to run operations more effectively. But that hasn't actually materialized. And what has happened is, if you can see what's on the screen now, is in 2016 alone, where more data was created than the previous 5,000 years of existence. And that is about 2.5 quintillion bytes. I can't even fathom that number, but to try and make it more tangible for most people, that's about 10 million Blu-ray discs, for those of you who don't remember what Blu-ray discs are. 10 million Blu-ray discs per day. Of access to IoT devices and making them more accessible to the market, this is only going to increase, and this trend will only continue. So I've put this up here, and I've put this drawer up there because what's actually really happened is with this massive volumes of data and these explosions in the number of data that we're getting, data has turned into, I think everyone has that drawer where they put all those odd things that they don't really use, the USB cable charger, all the USBs you get from SIM conferences, all these little odd things that you get, you just throw them in that little drawer at the bottom of your other drawers. And that's what's sort of happening with data. They're getting so much data. It's being stored on, obviously not in drawers, but these servers which act as virtual drawers. And this data, if it could, would be overflowing, and people having to buy more storage and just find these massive storage facilities just to store and manage this data, and spending a lot. And the unfortunate part is not even a percentage of it is being used. I mean, the most recent research I saw on it is we're not even using 0.5% of the current data that we have. So it begs the question that is data proving to be the new oil? Although in COVID times, of the recent slump in oil prices, it might be more valuable than oil. But it hasn't over the years since this advent of digitalization and big data proven to have the value that everyone hoped that it would have, and mainly because we haven't been able to use it effectively. Now, to put that in a bit of more context, especially in the mining environment, this is something from Komatsu, a quote from their website. They are claiming to be able to produce 60,000 data points per second from their mining products, from their machines. And this was in 2018. And they were estimating that 5 years from 2018, the number would grow to 500,000 data points per second. Now, and this is expected to still also grow. So with better computing, Moore's law, we're getting better computers every 2 years. The capacity is doubling. That's expected to increase. And again, it's just proved the point that we have so much data that we don't get to even use half of it because we don't know how to use it effectively. So this presents a challenge, right? It presents a challenge for the mining industry, but not only the mining industry, but all organizations. I mean, we work across industries, and what we see in mining, we see across all other industries and all something at any given time in the past, however long your company has embarked on this data journey, someone in your organization has more than likely made some sort of poor decision or mistake based on information that was very expensive to first collect, store, and make sure that person had access to it. But at the end of the day, it ended up landing on the person's desk, and a poor decision was made from that information that was handed to them. And this is just a testament to the fact that if not done carefully, these large investments that are being made into digitalization and data analytics will actually prove not only to be of no use or limited use to organizations, they may in some instances be harmful to the actual organizations if not used properly in the correct way. So the big challenge is, how do organizations incorporate data into complex day-to-day decision making? Right? I guess that's the ultimate goal. That's ultimately where everyone wants to be. It's how do I take my data, turn it into something that I can give to my employees, people on the shop floor, people who are making the decisions day by day, to simplify their lives and to make sure they're making the right decisions. So that is the big challenge. And that is the challenge that hopefully I can give some pointers towards overcoming today. So, so one of the biggest reasons why this is the case, that we're not leveraging our data as properly as we should be, is that if you think about it, any organization is a very complex system of interconnected activities. It's dynamic, especially in mining. Today may not be the same as tomorrow. Everything is always changing, and it's already complicated managing this organization, right? There's people issues, there's all sorts of other issues, external issues you need to worry about. And on top of that, now we're adding this added complexity of digitalization and data, which is further adding to the noise. It's just adding noise to an already complex situation to try and manage and handle. So what we're finding is that leveraging data is actually a lot more messy and complicated than in reality, right? In reality, it's very difficult to take big data, as the image shows it, and turn it into small data that's actually practical and applicable for people on the ground. So it's something that a lot of organizations are starting to be aware of, that when you embark on this journey, it really needs to be focused on how do we make life easier to help them make better decisions on a day-to-day basis. So if I give an example of mining, right, as a complex system, as I mentioned, of interconnected activity. So you have, at the beginning of it, you have resources, right, which is people, machinery, all sorts of tools that you use to actually do your processes, all the way from drilling, blasting, loading, hauling, all the way to the process, and you have the final product. And all these resources have of late been kitted out, right? A lot of them, like the Komatsu one, electrified. They have instruments, they have devices, IoT devices, streaming millions of data now per minute to some sort of MES or control layer, which then is meant to take all this data, absorb it, try and organize it in a way that makes it possible to give some sort of practical data and information, right? So it's supposed to turn out data and information that's available for people, with the ultimate goal of making, right, and getting insights from that information. So it's basically a process of here's my fleet of machinery or my resources, including my people who will have wearables now who can also generate data. Kitted with devices, instruments, expert systems, taking all that information, taking it into a control layer that tries to manage all this data and make it into sort of digestible data information, and with the aim of making actionable decisions and insights. Right? So that's the whole idea, and that's the whole intention of the whole digitalization of data drive. However, what's mostly missing, and what we're finding, and that's where we focus a lot of our attention and energies, is in that people side of it and the sort of organizational side of it. And how do we enable people across disciplines, across roles, across job functions, and enable all of them with all this data that's being given to them to make those actionable decisions, right? That's currently the gap, and that's currently where the missing link is from actually getting the data. I think over the years, technology has advanced at such speeds that getting access to the data isn't as much of a challenge as it used to be. The biggest challenge is taking that data, giving it to people who still have to make the decisions in most parts. I think we're still a bit far away from having AIs completely making decisions for us, machine, human hybrid. But as long as humans still have to make decisions, we need to enable them to better make actionable decisions and get insights from the data information that's given to them from the system. So this leads me to my first pitfall that we see that organizations land into, right? It's because of this, the lack of understanding of the system and so much data being streamed to me at one given time, we're finding that most people are data and information overloaded, right? We're just giving people everything about everything with the hope that more is better, right? More is better than less. And the more information people have, the better decisions they're going to be made. But what we're finding is this is just leading to frustration and a lot of overload on people who are absorbing this. But now, especially with mobile devices, people are getting data via WhatsApp, people are getting data via SMS. So it's this constant, feed of data that's coming to people that are supposed to be managing the organizations. And it's causing frustrations on two fronts. It's causing frustrations because the people on the ground don't know how to actually, decipher and decide what to use and what not to use and how to use it effectively. So they end up being overloaded and just bombarded with data. And it also has frustrations from senior leadership and executive management because they've put in a lot of investment, they've put in a lot of effort in getting this data to people so they can make the right decisions, so they can improve business operations and increase productivity, increase output, is the ultimate aim. But it's not happening or not happening at the speed that people expected. So there's a bit of frustration from both sides that it's not achieving what it's supposed to be achieving. So the result of having too much data and data overload is number one, a lack of focus. So greater visibility to everything has the risk of making it more difficult to focus on the right thing. So if I give you access to all the data, everything that may have been known before, but now that it's visible, you have access to it, and there's greater visibility to problems that may have been there, but may not have been the right sort of problems to focus on, or may not be priority problems to focus on. Because now there's greater visibility and everyone can see it, and because of business pressures, we end up with people doing analytics for analytics' sake. Right? We need to analyze all the data, and we miss out on finding the key critical data points that need to be analyzed to give us the best bang for our buck, biggest bang for our money and time, so that we can actually deliver the return on investment. So that's basically resulting in us missing the target altogether and not realizing the value of data. So to help counter this, one of the things we've been advocating in industry, especially in the mining industry, is the first thing you need to do is understand your system. Right? This is where our sort of system thinking approach comes in. So if you remember the mining system that I showed you earlier, so what we're saying is then take your mining system, look at your end-to-end value stream, all the way from drilling, blasting, loading, hauling to processing, right? Your execution processing stream. And say, let me look at this value stream. And from this value stream, let me do a value stream mapping exercise. Right? with the main intention of, out of my value stream mapping exercise, what I'll get is I'll be able to identify my constraining activity. It may be drilling, blasting, loading, in this example, crushing. So if crushing is my constraining activity, ideally what I should be doing is focusing all my data analytics efforts on the constraint and subordinating all the other activities. So with the knowledge that crushing is where my limitations is, I can then go on and put as much IoT as I want in there to make sure that that piece of equipment is running as effectively as possible, do as much predictive analytics as I can on it, like really get in there and try to make sure that I fully understand how the thing is working or how that unit process is operating, and optimize it and maximize it, because once it is operating suboptimally, everything else will operate suboptimally as by virtue of it being the constraining activity. So in addition to that, I mean, this looks like a gimme, but you'll be shocked at how many times we get engagement with clients, and the first thing that we really need to work through is helping them and spending time defining the problem that you're actually solving for it. We usually take this for granted and say, oh, we all know what we're trying to do. But in most instances, not everyone is clear on what the problem is. No one is clear on the approach on how the problem is going to be solved. So we really advocate for spending as much time as possible up front defining the problem so that you know where you need to focus your energies and all your attentions, so that you're not having to spend a lot of time on unnecessary activities that are not really going to generate value for you. So this is what we advocate as the beginning point. You really need to understand your system, and it has other implications as well, right? It has implications on how you use your resources. Like I say, if you focus on crushing, you're able to help people focus. Then do 101 things at once. You can manage your capital expenditure a bit better, so you're not spending and putting IoT in everything and paying for huge data storage services. You're only managing the ones that you know are critical to making sure your organization can run or your system can run optimally. So the first and most critical thing to do is understand your system, understand your constraints, and identify the problem you're solving for, so such that it's clear and everyone understands the common approach towards tackling the problem. The second thing that we're seeing is initiative overload, right? This feeds from the first sort of pitfall, which is now we have too much data. Now we have all this data available to us. Now we want to do something about everything. Right? There's all this stuff that's showing us that there's greater visibility. We're seeing this is operating suboptimally, that's operating suboptimally, everything's operating suboptimally, and there's an initiative for each one of those sort of suboptimal performances. And all this leads to this initiative overload. So all this data and information overload is leading to initiative overload, and we're not able to focus our organizations properly. And this is as a result of, if you look at a typical control chart to manage a certain process within a processing system, there's expected variation or noise within the system, right? And this is what is called common cause variation, right? This is variation that you can't avoid. It's variation to common chance. It's expected variation. It's what we call the voice of the system. Right? And what usually happens is, because of business pressures and because we put a target line and if up is good and down is bad on the graph, anything in that green sort of block that is below the target, we see it as bad. And each one of those, in most instances, will get a new initiative and a new initiative owner and someone to investigate why that went wrong. And not understanding that that is actually just part and parcel of the normal common variation that exists within a system. So we should really shy away from spending time chasing common cause variation. We need to understand what the noise or the voice of our system is, how our data sort of performs with expected variation, so that we're not really chasing noise, so that we're really chasing the critical things that are going to give us value for money. And these are what we call special causes. So the little red dots at the top are the signals for unexpected variations, which are your control limits, which is statistically calculated. Any sort of statistical package, you can take your data and you can actually compute those limits to see where your limits are for your individual processes or your overall process as a whole. And that should be a signal to when you should actually take action on a day-to-day basis. So the first thing is to not have the target there. So that is the mean instead of the target on the top graph. So it's just like I mentioned, the voice of the process. It's just what the process is telling you. So that is just the average or the mean of the process. And you obviously have your standard deviation, and there's certain rules to apply, but generally the most general one is anything outside your control limits, upper and lower control limits, is worth investigation. So that's a special cause. So that will help limit the amount of initiative overload. So not chasing common variation, but focusing on true special causes that are unexpected or show an abnormality in the way the process is operating. The sort of other thing I wanted to highlight is the fact that improvement is seldom linear, right? If you look at progress of anything over time, there's an interesting quote that I recently came across that we usually overestimate what we can do in a year and underestimate how much we can do over 10 years. And whenever we do projections, you see it when the person does either a projection for a project, it's always this linear line and it's always going to go up and up and up and it's all going to be good. But the reality is very rarely do you get improvement curves that follow a straight line. So if you see the red line there, right, that's the actual data. So the trajectory was where you thought you'd end up with a dotted line from where you are. But over time, you've actually done well. But if you look at that red line, it was very up and down, right? And at any given moment, there might have been an urge to react, there might have been an urge to overreact and overcorrect, right? Without looking at the overall trend, which is the trend going upwards, which ends you up where you actually didn't expect, right? Very seldom is it exponential as it is in this curve. I mean, this is just for illustration, but usually you'll have a little bit of an S bend at the end, which shows that you're starting to hit your system constraints and the limitations of the effectiveness of whatever solution you've put in place. So it won't always be exponential as this is, but generally we'll end up where we didn't expect, far better, but only if we understand that improvement doesn't follow a straight line. It will have ups and downs as you discover new things, hit a few challenges, hit limitations, you start pushing the boundaries. It's about understanding when to react and how to react and not to overreact and overcorrect sometimes, which can actually and actually take you a step backwards. And what I wanted to introduce to you here with some data that we did for some work we did recently is things can be bad and better. So that's a very interesting concept that I also recently came about and something that ties into the fact that there is no straight line improvement. Right? So if you look at this sort of graph, this control chart, the sort of initial phase, which sort of is over here, which shows that the mean was pretty low. So the target is the orange line. So all the data is below the target, hence the bad part. All the data is bad if you look at it from that's my target, that's what I need to be getting, this is where I am. But if you look at it objectively and you start looking at different phases where you can start seeing some sort of trends, right? You start realizing that there's some sort of incremental trends linked to some actions that were taken that starts emerging. So this is a sort of a different perspective I want to introduce to say it is possible for things to be bad and better, which is something that we don't usually think of data that way. Right? It's either good or bad. So it's good to differentiate between level, which is it's either good or bad, or sort of what direction the data is taking. Is it getting better or is it getting worse? Right. So even though it's bad, there's always, if action is being taken and you're seeing results of that action, and the data is becoming better, again, it's another caution to say don't overreact, continue on the path, and eventually it will get to where it needs to be in terms of the path that you're following. And it also limits the initiative overload that we spoke about earlier, that we're chasing every single time we're below the target. We're creating new initiatives, which ends up with people just doing too much and ending up not doing anything actually effectively in the end. Okay, so that's pitfall number 2. Pitfall number 3 is comparison of averages, which can actually skew your perspective on data. And it's a common mistake that we see that people make. Averages are good because people like using averages. We also use averages. They're a good indicator. It's quick, easy to calculate, and it gives you a quick indication of where you are, right? But we must be very careful of comparison of averages and using it in certain instances because it can distort our perspective and our view on the data that we have. I mean, even on this graph itself, all this data has the same meaning. It's quite different. So averages have their place, but we must be careful of comparing variables too often using averages. So if I can just give an example of this. So the data you're seeing there is from the USA, the SAT results, which is the equivalent of a matric result, I guess, yeah. And if you look at this data ranging from 1977 to 2016, so this is the average math score, that how males and females perform in the actual test. And you look at the trend over time, right? This trend tells us men are better than women. Men are better at maths than women, right? And there's a gap. There's a clear gap between men on average than women. Men on average just outperform women, if you look at it from this perspective. However, if you take the same data and just look at it from a different perspective, and you take the data and you actually put it in a distribution, so you get the number of individuals with the different scores, across different scores, then you see there isn't that much of a gap, right? You actually look at it and you see that the curves almost fit on top of each other. So the gap doesn't really exist. There's just a higher proportion of men who sometimes get higher marks, but it's not to say there's this gap between how well men do and how women do. So just changing that perspective on how you look at the data and not just looking at averages, but looking at the overall spread of the data can actually make the data much more valuable and prevent you from falling into a trap of making a conclusion that is probably inaccurate or not the most effective, or won't give you the most effective results by making the decision. So comparison of averages is something to also be very careful of. Although averages are very good, they're very useful, they have their time and place and they shouldn't be used too often. Okay, now pitfall number 4. Pitfall 4 is all about the confusion between reporting and analysis. Right? We find this a lot. A lot of people are reporting on data because the data is more accessible. There are a lot more tools available for you to do reporting, some tools that automate the reporting for you. And a lot of people take this as we're doing analysis. Right? And most people aren't actually doing analysis, they're just doing reporting of the data. Just to give you just a bit of an understanding of what the data reporting, the way I see it is how do you structure, right? And how do you structure your data in some sort of summary, your output data, to monitor system performance, right? Across whatever part of the process you want to be measuring. So that's basically reporting. So it's a summary of output variables or outputs from your system that help you monitor how well your system is performing. Analysis, on the other hand, is using statistical and other techniques to actually extract insights from the data that you're reporting on to empower decision making. So it's about how do I take the data that I'm reporting on, using the techniques that I have, statistical or other, to actually get insights that can enable decision making. So it's very critical to understand that data analysis doesn't end at here's a report, here's a dashboard, here's the data up visualized. There's actually more to be done with that data to actually get analysis and insight. And that is where we find a lot of organizations are still low in maturity and still have a lot of work to be done and a lot of skills transfer to be done in order to enable them to better understand how to do that more effectively. So if I just give you a mining example, right, I'll just take one metric and just give you an example of the differences between the different terminologies. So in any sort of mining operation, you might have a cost per ton metric. Right? So that's the metric the output metric you're measuring. So at the end of the month, you'll have a metric, cost per ton, that you measure. Reporting on the metric would be saying the cost per ton was higher, the average cost per ton for last month was higher this month than it usually is. So that's just the report. That's basically, it could be in a bar chart, it could be in a line graph, it could be however way you want to display it. So it's just showing you that on average, the cost per ton was recorded higher this month than last month. Right? But that isn't any form of analysis yet. The analysis piece comes in when you start asking the question, like a similar one here, like why is there a higher than average cost per ton this month? Especially considering we had lower than average outputs. So we produce this, but our average cost per ton is higher. So that's where you start doing your analysis, asking those types of questions. Okay, what is this data telling me about my operation or my system? That's the analysis, and the actual insight that come out of that is to say, based on this and previous month's analysis, right? This month's analysis and the previous months that I've looked at, this is what we can do to improve, because it isn't just based on a single data point. Insight is a culmination of data analysis over a period of time. So if you take all the data analysis over a period of time, put it together with the trends that you see, with asking the right question, you're able to then draw insight from the data, and you can then start doing business improvement and improving your project, your operation, to operate more effectively into the future. So just the key to understand that there's always more to be done after reporting. So we're seeing a lot of reporting being done, but bridging that gap from going from reporting to actual insight is still an area that needs a bit more focus, especially in mining. Okay, and then pitfall number 5 is too much data and too little judgment. Now, this is an interesting one, because now this is where we start bringing that people element of it a bit more. So yes, you can focus too much on data, because as I mentioned in the beginning, especially in mining, most organizations or most systems are dynamic and are not very predictable, right? So the data alone may not be able to give us all the answers we need all the time. So based on some study that was done by the Harvard Business Review, with over 5,000 employees at 22 global companies, they sort of came up with three groups of people within an organization. You can class them as. So you find the unquestioning empiricists, which trust analysis over judgment. So give me data and only data, and I don't want to hear anybody's opinion. I don't want to hear anything. Only the data is going to give me the answers, and I trust nothing else. And you get the visceral decision makers who go exclusively on their gut, right? And I think, especially in the mining industry, you see this a lot based on experience. I've done this before. This is what I think it is. I mean, yeah, how long is a piece of string? It's just, let's just make the decision. It's my gut feel. I feel like that's the right decision, and sometimes it works, sometimes it doesn't. And then there's a third group of people, which are the informed skeptics. These are the employees who are best equipped to make good decisions. So they have a good balance between using the judgment and analysis. So these people have good analytical skills. They're able to engage with other people, listen to other people's opinions, but they're also willing to give their own opinion and disagree if necessary, in dissent, into engaging debate, engaging conversation to say, but about having good strong analytical skills, being able to engage people, and being able to have open and sort of fair debates about what the data is telling us and what the people are telling me in terms of their sort of judgment as well. So these are the sort of people that, according to the study, and I tend to agree with it, that most organizations need to be cultivated. However, in this particular study, they found that only 38% of employees and only 50% of senior managers fall into this group. Right? So not everyone has this well-rounded skill set to take data and use it effectively. Right? Either they go to either one of the extremes, either they use too much data, not really trusting any of their judgment, or they use only their judgment and don't use any of the data. So there's a fine sort of mix of both that is needed to effectively manage and use data effectively. And the way I see this all comes down to skills and capability development. And if you look at any organization has a typical S-curve, right? What we are finding, this is some work that we put together across industries. Most operations are performing well below where the performance potential is, right? Probably most around the 30-40% mark of where they could potentially be performing. And what we're saying is there needs to be a skills and capability development maturity, right, at an organizational level to move people along on their journey, because the last thing you want to do is leave the people behind and only empower a limited amount of people, which is what we're also seeing a trend that's starting to emerge. There is a data analyst that's brought in, or there's Lean Six Sigma specialist who's brought in, who's very good with data and understands the data, but it's only them and only they can do it. And so it's a very isolated effort. There needs to be a drive towards developing the whole organizational maturity towards that, and making sure everyone has some sort of level of understanding and some sort of ability to engage with the data and use it effectively. So if you look at the continuum at the bottom, there's some prerequisite skills that you need, which are facilitation and flow, which I'll speak to a bit in the next slide. And as you move along the organizational maturity and moving yourself off the curve, you'll start with some basic reporting and analysis sort of capability. And gradually, I think that's the point I'm trying to make it, it's a gradual sort of migration towards advanced analytics and insight. Jump from where they are that basic reporting and analysis phase. And a lot of them are just trying to jump to that advanced analytics by sort of throwing someone in there with those skills who's going to work in isolation. But without taking the entire organization along on that curve, they're not seeing that jump happen. That's because, as I mentioned, it's happening in isolation. So I talked a bit about the prerequisite skills and of facilitation and flow. So, I mean, any sort of digitalization or data project shouldn't be seen as just another project. I mean, if we fundamentally intend to change the way we do business and intend to change the way we use data, it needs not to be seen as just another project. It needs to be seen as a facilitated effort across the organization at a system level to say, how does it all fit together, and how does data touch on each one of those different value inputs in our value stream, and how do we effectively use that data to make decisions. So currently what we're seeing, again, similar to the fact that you just throw people in isolation, these projects are also done in isolation. They're not done with the people on the ground in consideration. And that's where they're hitting a lot of hiccups. We're finding a lot of organizations where millions have been spent, the system is ready to go, but I mean, the people on the ground just say, I mean, having this information is not really going to benefit me anyway or help me do my job better. So it needs to be seen from a system perspective and not just as an individual project. And as I wind down for my presentation, it's just a summary of what I was saying in the previous slide. It just needs to be an integrated system approach. There's systems, there's processes. Those systems need to be formed into some sort of processes that employees can use, that people can actually use, and provide value for customers. And this concept of customers is something that isn't really explored, especially in mining, but it's something that we always try to highlight to people, that customers does not necessarily refer to external people. A customer can be an internal customer. I mean, the mining customer is probably the plant is the refinery. Even within the plant, if I'm the crushing guy, the mill might be my client, so forth and so forth. So we need to get that sort of mindset to understand that there's systems and processes that needs to be set up to enable employees to do their work as best they can so that they can service the customer. I think if we can approach or adopt this customer-centric approach, then clients, I mean, if you go into a shop, I think any of us go into a shop, we expect to be treated cordially, we expect to be treated a certain way as a customer. Right? And we need to start developing that culture within organizations that whatever I'm touching on, I need to understand how it impacts the next person who is ultimately my customer. And as the saying goes, the customer is always right, and I need to make sure the customer is always happy. So as I conclude my presentation, I just thought I should just do a full 360 back to where I started as to what the initial intention was. And I hope I covered all of it sufficiently to help you sort of, one, recognize some of the pitfalls that are out there when using data. Which can then impact on your organization negatively, but if used correctly, can have a very positive and very drastic positive impact on your organization as well. And I hope you've picked up some of the key sort of tools and sort of insights that I've shared as to how you can actually avoid some of the pitfalls and how you can better position yourself as an organization to using data better and making more fact-based decision making, and improving your overall operational effectiveness. And that is the end of my presentation for today. Thank you.
Thank you very much, Anthony. That was definitely a good overview, I think, of things that we sometimes see as obvious, but perhaps when you get to these things, you forget. I particularly liked your presentation of averages. It's something we use all the time, average grade, average recovery, average whatever, and we forget that that's not always the ultimate answer to our problems. Generally, so I think you gave us such a nice overview. We're only getting thank yous, and like I see a lot of thank yous coming in on the chats. So okay. We have our first question from Jason. Perhaps he says, "Hi Anthony, fantastic summary and insightful. A curveball question. When will recruitment processes actively seek informed skeptics and stop employing a surplus of yes people in high agreeableness? Is this a subconscious bias by management for a team which doesn't question their orders?" What is your answer to that one?
Yeah, look, it's a difficult. I'm not an industrial psychologist by any means, so I'll answer it as best I can based on my experience. It's a difficult skill set to put together because not necessarily an inclination to hiring a certain type of people, but for me it's the fact that those people who are able to use the data effectively. For me, it's a very rare combination of skill to find in people because it's not taught. Right? I found it that personally myself. I don't know if people have a different experience. I was never taught that at university. I had to learn it myself, through other means. So it's for me, it's still a journey that as organizations, like I said, across industries are going through. And I think more and more of them are starting to realize the value of these people who are able to take the data, interrogate it, but also involve people and have that combination of skill. But it's for me, if as a young professional, representing the Young Professional Council, it's something I'm always advocating to young professionals is that ability to have both is going to be such a critical asset going forward in the future.
Yeah, I think from my point of view, coming maybe from a more research background, that is absolutely important to always question and interrogate. And if you are, I do think that at a bachelor level, perhaps we're not taught sort of skepticism as much as we can, but that's where I think going for a master's or another postgraduate qualification often helps you sort of sharpen your tool set for that kind of scenario, because you at least need somebody on your team that is a skeptic, informed skeptic in using your words. And I think that's a very nice review. So there's also a question here from Quinn. In metallurgical engineering, data overload is definitely a problem, especially when combined with decision makers' highly variable skills levels. We see a lot of low-hanging fruit in data analytics as lying in simple data digestion, simplification, and summarization. And his example is sort of a digital assistant tool for plant operators. Would you agree to that comment?
100%. If you remember the sort of maturity slide that I showed, the first thing is from where you are. I mean, start with where you are with basic reporting and basic analysis. Excel, the simple Excel plugin tools that we use, that we help people and train them on to use before you get into your big data, big analysis, complicated programming stuff. So definitely agree. I mean, there's a lot of low-hanging fruit. If there's so much data that's already available that's just not being utilized. If you can just take that and just make it applicable to the guys on the ground, it can already generate so much value. So 100% agree with that approach. Start small and just take gradual incremental improvements.
Yeah, but using your data, I mean, we have here at my home, we always debate how, Excel versus using the modern tools of Python and, all the other plugins that you can get. And one of the things that we come to a conclusion on every time is that on the plants, Excel is still the basic, most familiar tool and people are comfortable with it, but does not mean that you can't use clever tools in the background to make it easier for people to digest. And I think that sort of answers a few of our questions that's in the pipeline already. I have another one here from Gary on the he's saying, do you think the mining industry has the required skills and capabilities to use their own data?
Currently, probably not. Currently, they do not. That's why there's a lot of reliance on external service providers. We see that's what we've seen a lot of engagements with clients. So currently, we're seeing that is a critical thing that is lacking. So that skills and capability development, which is a key focus of what we do as well with our partner company, Simmine, which is basically upskilling and giving people these sort of skills and capabilities, not only from a understanding data, but from what I mentioned earlier, just overall understanding your overall system and how your system works first, before you even try to use the data on the system that you don't understand. Rather, understand your system first, understand where your constraints are, and then you can use the data more effectively. So definitely, I think there's still a lot more work to be done there in upskilling in the mining.
Yeah, so I mean, some of these questions are about how do we deal with that, where people in industry don't really particularly like change. How do we get metallurgists, production overseers, etc., change their feelings towards migrating to Excel, from Excel to cloud-based software, for example? I'm pretty sure you guys have experience in that.
Yeah, look, change is always difficult. So there's two ways of getting people to change, right? One way is to make it pleasurable. If changing is going to be pleasurable, then definitely I'm going to change. Because change is usually not comfortable. A lot of people aren't comfortable. A lot of it is I hope I'm not speaking out of turn, but some of it is ego based, and it's the fact that I don't want to feel like I'm now becoming obsolete. Now I don't understand this. I can't endorse it because I don't understand it myself. So it's either one, making the change comfortable and making it pleasurable to change, or two, usually call burning platforms, is to make sure that if you don't change, then it's going to be painful. So there's one of two ways. So it's either making the change as comfortable as possible, or making not changing uncomfortable, which forces people to move. So there's different ways to deal with it. But yeah, it is a definite challenge, and it does take time. Unfortunately, it's not an easy thing to change.
I think it's like everything, Anthony, to you, the value proposition for the guy who has to change has to be sold. You have to tell him what is the benefit for him personally. And if it makes his job easier, or it makes him more sellable in the market, whatever that is, you have to sell it to him. Usually people like it when things make their jobs better and easier. So we have to do a better job at selling this, I think. It's one of the, another comment here from Quinn is about AI and how the trend is towards the combination of human and AI. The research is showing that the approach is better if you have human and AI combined rather than AI only, to help you with decision making in organizations. So this seems to align with your informed skeptics concept as well. I mean, I presume you agree.
Yep, definitely agree. I mean, one example we like using now in organization is South African organization. Well, at least I do. Elon Musk, everybody doesn't identify South African. I mean, he built a whole factory where they built the first robots. The robots went on to build the robots that went on to build the cars. So there were no people, so they had robots building robots that are going to build the cars. And I think we all know what happened when he fell behind with his production of the Model 3. And what actually ultimately ended up helping is he put people back in the factory. And he actually had to swallow his word and fall on his sword and say, he made the comment that people are probably the most undervalued resource we have on this earth. Now, you know, it's still happening to some of the people who believe that technology is the only solution. Many of them are quickly learning that we still need people and that judgment from people to make it all work.
So that is so true. I think that we cannot replicate as that whole jumping between things that doesn't seem connected, but a big data analysis can give you a lot of different pictures and perspectives that your brain cannot do, at least not unless you're a supercomputer. And then we can use that again to get to the next big set of data. So I fully agree. I think that the combination is where the magic lies, actually. So here's a question for you. Something that perhaps in your interactions with the mining and minerals industries that you've worked with, what was the biggest value drivers that you find in terms of increased performances that you've picked up when working with different clients?
So it varies from client to client, but the most critical thing that we're finding is just the ability to, well, first understand the value drivers, because sometimes we get on a site and the value drivers are not understood, right? So in terms of my overall objective, what are all the different values? But in terms of specific value drivers, it depends on site. It's site specific. But from our perspective and the work we do, the biggest value we see is just from using what we call collective intelligence of the organization. Right? What we find a lot is people work a lot in silos. What really just putting the right processes to make sure everybody has the right information, everybody's doing the right work when they need to be doing it. and there's always a positive feedback loop for that continued improvement. We're finding that alone, just getting that in place, can give you up to 30% improvement just on that, just using the current people we have, current processes, just improving them, making sure people have access to, I know what I need to do, I'm doing the right work, I have the right tools to do my work, and opening up those communication channels. And I mean, you see a significant improvement just by doing that.
That's a great answer. I think it's something that we often see in our own lives. You work in a little silo, but there's people doing the same thing elsewhere and redesigning the same tools. And I mean, but just being able to leverage what you have in an integrated manner is already a massive, massive win. So here's sort of, I'm going to combine a few questions here for you because it is quite an interesting one. Do you think over and above our general engineering techniques, should we then advocate for more data science in our mining and metallurgical engineering degrees?
Definitely. Not only that, but just a broad range of different sort of disciplines. We're advocates of broadening your understanding and broadening your thinking. I mean, your general engineering degrees, I'm fortunate to say, I mean, in most, not only South Africa, but most countries, most general undergrad degrees are not probably going to be fit for purpose for the future of mining, the future of work in general. And we're seeing a lot of movement, people actually moving towards these sort of hybrid, create your own sort of universities. I mean, a lot of countries are actually playing around with the idea. Some of them are actually piloting it, where you can have this lifelong degree and you can mix and match what you want to do. I mean, you can choose to do drama and maths and biology and whatever, and mix and match and create your own sort of unique degree. And you can do that for as long as you want. I mean, you can just come back and say, oh, I think I need a bit of data science. Go back and add that. Oh, I need a bit of this, of lean or systems thinking. I need to get a bit of that, So definitely, I mean, for me, it's not just the data science, but it's just lifelong continuous learning and just broadening the disciplines that people approach.
Yeah, I cannot agree more. I mean, I think even with my relatively advanced age, so I do benefit from doing courses or doing a postgraduate degree. Even if you do it, you realize your tools that you need. I mean, one thing that I remember from my days of varsity is that the first year or so of our degrees, we had a common subjects as engineers. Whether you were a chemical engineer or a mechanical engineer, we all did physics and chemistry and math together, and perhaps there's some valuable lessons in that we should do more of those optimization courses together with other disciplines so that we don't split apart so quickly. So I think that will bring us to today's end. I think we've already run a little bit over time, but I think it's always a good sign that people are wanting to engage with you. I'm sure you won't mind if people send you an email and for specific questions afterwards.
No, I will not. And I think the presentation will be shared as well.
Yes, we will share the presentation with all the registered attendees. And from my side, again, Antony, it was an absolute pleasure having you here today. And I hope that you get bombarded with lots of questions via your email inbox afterwards.
Thanks, Isabella, and thanks to everyone who attended. And
thank you so much for your time. Okay, thank you.
Have a good day.
Okay,
Thanks. Bye.
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 Improv.